We've discussed quite frequently the necessity for generating unique hash values for our blocks. This hash value is generated from all of the data particular to that block, including its timestamp, the given data it's storing, and most importantly, the unique hash value of the block that came before it. For our hashing function, we'll use an algorithm called SHA256, which stands for Secure S Hash H Algorithm A 256. The 256 part represents the fixed size of 256 bits for the hash, which is 32 bytes, or in other words, 32 characters that will be generated to represent the hash. So this hashing algorithm has some nice properties to it. For one, even if one character changes in the original data, the SHA256 algorithm will produce an entirely different unique string of characters for a different hash. But it will always produce the same hash with the same given data. Another unique property of this hash is that it's a one-way function, meaning it can generate a hash from some given data, but it's pretty much impossible to decrypt that hash and get the data back. So it only works one way, from the direction of the data to the hash. Now, this is useful when it comes to validating blocks. If a set of data produces a unique hash, then in our blockchain system, we can immediately know if data has been tampered with, if its generated hash is different from one that we create given the data that is already there in the block. All right, let's add this SHA256 hash function to our project. To begin, head to the command line because we're going to be installing a new module, so make sure you're in the SF chain directory. This new module is called crypto-js. Crypto.js is a neat module which contains an SHA256 function that we can use. So let's install it. npm i crypto-js, and we'll save it. So we'll save it with the --save dependency, so that way it's listed as a dependency in our package.json file. So if you cat out the package.json, you'll see that there is a dependency of crypto.js, or rather crypto-js, in the project now. All right, now let's go back to our code editor, and we're going to take advantage of that module in order to add a hash function to the block.js file. So make sure you're in block.js. And now, at the very top of the file, let's access the SHA256 function and store it in a constant also called SHA256. That is all caps. So that's SHA, all caps, 256. And then we're going to set it equal to requiring the SHA256 function from crypto.js. So it's crypto-js slash, this time all lowercase, SHA256. So this will be a function now, which is a hashing algorithm which generates a unique hash based off of given data. So now let's add a new static hash function to the class. So underneath mine block, let's add a new function called hash. And this hash function will represent the unique data that we want to generate a hash for, and that is the timestamp of the block, the last hash of the block, as well as the data that the block is storing. So now as a result of this function, we're going to return a call to the hash function we required, which was the SHA256 function. So we're going to return, in all caps, SHA256, which is the function we required at the top. And then the input is the unique data that we would like to hash. For us, that's a combination of all of these parameters. We'll combine them as one input by using an ES6 template string. So we'll use backticks, and that's the one key, or rather the key next to the one key. Notice that they're diagonal ticks, not regular commas. And then for each piece of data that we want to insert, we'll use $sign. So there's three of them, or rather $sign curly braces. For the first one, we insert the timestamp. The next one is the last hash, and the final one is the data. So again, we're combining all these inputs as one string using an ES6 template string. And finally, let's call toString on this hash function since it returns an object, but we want its string representation. And great, we have the hash function set up. So now we can get rid of this to-do and replace it by calling block.hash and giving it the relevant data it needs to generate that hash. So we'll give it its timestamp as the first parameter, the last hash as the second parameter, and finally the data that we're storing as the final parameter. Okay, great. As we save this, we should be ready to go back to the command line, check out the dev test script, and then see if we have a unique hash value for the mine block that we're currently testing. So go back to the command line. You can go ahead and clear your window over there, and then rerun npm run dev test if you don't have it running already. And the output that you'll see is a block that is generated, and its hash indeed is a unique value, and mine is 0dcf9 ... Now, there's a 100% chance that your hash will be different because of the fact that your timestamp will be generated at a different time, and that timestamp is being used for the hash. To summarize what just happened with this hash function, as we called MineBlock in the testing file, we now have a hash value for the block based off of its own timestamp, the hash of the last block that we provided, as well as the data that we wanted to store. So this generation of hashes based on the last block is what links blocks together, ultimately making the entire blockchain. Moving on, let's build a more robust test around this block class.